You guys ready for the weekend?
Yes.
Yes, me too. I may actually catch up then. Dearly Father, we thank you for this day again. I thank you for these students. Just ask you to bless our work today. Help us to just to glorify you in what we do. And I just, again, thank you for your many blessings to us, Lord. In your name I pray, Lord Jesus. Amen. All right. So today we're talking about systems of equations. And really, systems of linear equations is what we're after today. And so a system of linear, we've already done this, right? We've already solved two equations and two unknowns. That's a linear system, right? But the one I want to focus on today is three equations and three unknowns. So this is the question, is how to solve three equations and three unknowns, or variables if you like. So here's the general strategy. Step number one, eliminate one or more variables by adding or subtracting equations. All right. Consider multiplying by number to make cancellation work. We did this already with the elimination, we had one, yeah?
Can I ask you a favor?
Sure.
Can you possibly write in the middle?
I will be. But I can't always write in the middle now. But what I can do, you can't see this at all?
I can't either.
All right, so there needs to be another row. All right, stop what we're doing. Well, let's take all of these front, so you guys can't see?
Not really, no.
Well, my eyes don't work, so I'm not a good judge. See, I really need all three boards, so if I start here, can you see here? So let me try again here. Strategy, and I'll try to write bigger. How about that? And by the way, thank you for asking that, strategy. So number one, I'm going to write a little bit less words though. All right, so eliminate variable. All right, you want to eliminate a variable from your system. How do you do that? Well, by adding equations or subtracting equations, all right? So eliminate a variable. And so what that will get you to is you solve system of two equations, right? See, if you can get rid of one of the three variables, then you've got just two equations and two unknowns, all right? And then we already know what to do, right? We've talked about that already this week, right? So you fall back on that stuff. And then step three is you plug back into one of the original equations, all right? That's one strategy. This is basically the elimination strategy. Let me talk to you about the substitution strategy. And I'll write it over here as to be, well, I guess I'm not mean to anybody over there. So the substitution, I can't spell substitution. Is that right? Yeah, that's right. Close enough.
Yeah, that's
Substitution strategy. I don't use this so much, but step number one, solve equation. Let me just use one for equation. Solve equation one for, let's say, z. All right? And then step number 2, plug formula for z into equation 2 and solve for y. All right, what would that give you? That would give you y. That would give you an equation which just involves y and x. All right. So we'll give you y as stuff with x, right? And then step number 3 is you substitute both the z and y formula into equation 3. This gives equation in x alone. You solve it. You solve it. Then you know x. What do? Then you go back and you can find the y and the z by plugging it back in to your substituted equations. Basically, then let me just describe it as 4 back substitute. All right. So let me see if I can illustrate this substitution method. All right, with my example 1. Oh. Sorry. I guess I'll go this way. I forgot to move it over here. All right, so not much to see there really. So let's look at an example. Example 1. Suppose we're up against the following: x plus y plus z equals to something, and then 2x minus y minus 2z equals to something, and I don't know, 3x plus 4y minus z equals to something. Now the question is, what should the something be? Let me think about this for a second. We'll see if it goes better this time. Last time it didn't quite go right. I had to revamp this 10 minutes later. That was no good. Let's do it right this time. 6. Don't look at me. See here, 2. Minus 6. All right. 8. All right, hopefully I have not made a mistake in creating this problem. Yes?
I was going to give this to you, but then I realized it's like
No, it's all good. I appreciate it, because if I ever lose it, then I'd be, I would never know what to do. Thank you, thank you. All right, so let's try to follow this substitution strategy. Let's try to put it into practice, all right? By the way, this isn't general. If you were to think about an arbitrary system, this wouldn't actually work, for the reason that I say solve for z in equation 1, right? How does that go if there is no z in equation 1? See, that could be a problem, right? If there was no z, how would you solve for z? You couldn't do it, right? So that's not a general strategy. It's a strategy that works when x, y, and z are present in the equations as you like. As long as all of the coefficients are non-zero, it works. But there are actually other ways to solve it when you have... Actually, when some of the coefficients are 0, honestly, guys, it's easier to solve than that. And so here we go. I was over there. I had oh man, I said my bad. I'm thinking of this as equation 1, equation 2, equation 3, but I use that for, I guess I got to call this example 1 today. Oh well. My usual, So E1, E2, you're none of us are as OCD as you are about that. So Relax. All right, great. So okay, so strategy. Step number 1, solve for z. Solve equation 1 for z. Can you guys tell me what it is? What do we got?
6 minus x minus y.
Very good. 6 minus x minus y, we have a winner. At this point, we have achieved step 1. Yay. Now step 2, plug the formula for z into equation 2. So equation 2, here we go. Plug that into here. So we have 2x minus y minus 2 times parentheses 6 minus x minus y, right? That's step 2. Well, the first part of step 2, right? What was the last part of step 2? And solve for y. Can you guys solve this for, oh, my bad. What am I missing? Is that an equation? What's that? That's what I call a floating expression, right? That means I don't quite know what I'm doing. You guys just told me I'd do what? Equal to what? Equal to minus 6. All right, there, I feel better now. I feel much better. Let's clean this up before I do anything else. This is 2x minus y minus 12 plus 2x plus 2y equals to minus 6. I just distributed the minus and the 2 through. All right? Now what?
Now
Combine like terms. Very good. So I've got this and that, which gives me 4x. And then how many y's do I got?
1.
Just the 1. And let's move the number to the other side. Minus 6 plus 12 is what? 6, right? What am I supposed to do here? What was my solve for y? Oh, hey, we got it, right? So this tells us y is equal to 6 minus 4x. All right. There we go. Let me call this star. Let me call this star star because we'll need them. All right? Then what? What's my step 3? Yeah, exactly. We use star and star star to eliminate y and z. All right? So we got what? We've got 3x plus quantity 4 times what? Times y, which was 6 minus 4x. And then z, what was minus z, which was what? 6 minus x. Parentheses are really important here. Be careful not to just, like the temptation, guys, when you're making substitutions, is just to apply that minus to like the first term in your formula. Like that's a very common place to make a mistake here. Be sure you're distributing the minus through all the terms. Now, pride goeth before the fall, so like the odds of me making a mistake about distribution are very high right now. But in half the time when I make like a comment about a mistake, like the next thing I do is make that mistake. I think God has a particular sense of humor sometimes. But he's in charge. I'm not, so what can I say? Let's see here. So what do we got? 3x plus 26. 26. Oh. The weekend needs to start. 24. 4 times 4 minus 16x. And then you just distribute the minus. Minus 6 minus minus is plus. Minus minus is plus. Equals to 8. And you guys gave me good. Why do I have a y there?
You forgot to put in the
Oh man, now what do we got to do? Yeah, we got to put the y in there, right? So this y we're supposed to. Let's clean this up. What do we got? Goodness gracious. It's not wrong what we did, it's just not done.
It should be fine, you just need to substitute the y.
Right. Let me do that first and then I'll clean it up. 3x plus 24 minus 16. I'm just copying it down again like a dummy. Y is 6 minus 4x equals to 8. Let me put some color coding here. All I did was take this y and expand it as that because that's star star. All right, now, finally, I have that equation that just has what in it? X. So we can solve it. What?
Wouldn't it be plus 4x if you had plugged it in and did the minus, like if you multiply it? Like if you had plugged it in the parentheses,
Yeah.
wouldn't that turn the sign around?
It shouldn't matter. I distributed that minus to minus, give me a plus y here.
Oh, okay.
The mechanics of what you're not seeing is like when I plug this into here, the minus distributes across both, which gives me a plus 4x in here, which then that plus hits that minus and gives me the minus. I mean, if you did that, you'd still get this as long as you take care of the minus, in short. How many x's do I have? 4. A total of 4? 17? Oh man. Minus 13. Minus 12. I got minus 16x, I think. Negative 15. Let me try again. 3 minus 16 is minus 13. Minus 13 plus 1 is minus 12. Minus 12 minus 4 is minus 16.
You're right, I just didn't see the extra x.
Oh, yeah. There's a lot of x's. It's like a Taylor Swift song. Let's see here. Sorry. You guys like Swifties or something? I hope not. I saw an adult man like declare he was a Swiftie, and I was like, that's not something I'd say in public. I mean, even if I was, like, it's like, it's kind of like this. Yeah. Is this anybody's? Well, you're not going to admit to it now, right?
I think it might have left it in class.
Uh-oh. Okay. I'm sorry. It's wonderful. But it would not be if I was wearing it, though, right? Can we agree that I shouldn't wear it, right? Yeah, okay. There are many things my daughter wears that I should not wear. That's in the Bible, actually, believe it or not. Let's see here, 24 minus 6. I think I'm starting to get into the territory where I might get in trouble with YouTube. Let's see here. 20. So the 6's cancel, right? And 8 minus 24 is what? Negative 16. Well, look at that. X equals 2, 1. All right.
Now just go back and plug it all in?
That's right. Now we back substitute. So then, up to here, and we get y is equal to 6 minus 4 times 1, also known as 2. Y equals to 2. Right? Then what?
You would put the x's and the y's into these.
Right? Oh yeah. Which equation? I should use the star equation, right? So star, I've got z is equal to 6 minus x minus y. Like you said, plug it in. 6 minus 1 minus 2, also known as 3. So solution equals 1, 2, 3. Hooray! This is the substitution method. It's pretty slow as they go, but it is reliable. It is algorithmic. You can write down the instructions on your formula sheet that you're allowed to bring to the test, right? On your formula sheet that I allow you to bring to a test, you could put this example with all of the steps that's allowed. You can put whatever you want in the formula sheet. A picture of your beloved, Elizabeth in poetry, whatever that is. I don't know. Quotes from Baby Yoda, like whatever, I don't care. Or math. You can math on the formula sheet. That's a good idea. My point to you is you can prepare for this problem. You don't have to come at it just hoping and praying you remember this system we have for solving it, right? Any questions about this? I'm trying to go slow to make sure everybody has time to ask questions. Let me solve this same problem using the method of elimination. How does the method of elimination go on this? Oh, yeah.
It doesn't matter what method we use for like.
Oh, no, you can use elimination or substitution. Either way is cool. But like the book's recommended homework problem, sometimes it says use substitution or use elimination. Like, I don't care. You can use either. It's all good. And of course, the answers are in the back of the book. The other thing I probably should talk about is like, what is a solution? What does it mean? So do you guys know? What does it mean to solve a system of equations? We're looking for what? A value for x, a value for y, and a value for z. All three, right? Three numbers that when we plug it in here, equation 1 is true, equation 2 is true, and equation 3 is true. We're trying to solve these equations so-called simultaneously, all right? Now you might wonder what that means. Well, let me tell you a geometric application of it. You guys play Minecraft, yeah? No? Somewhat. Ah, very good. At least one honest person. All right, so I've heard people play Minecraft. And there are coordinates in Minecraft, right? Like x, y, z?
Yeah, this is pretty easy to follow.
Right, yeah, exactly, right? I mean, I don't know, this should be like high school math, right? X, Y, Z coordinates, right? Very useful. Well, here's the thing. A plane in 3 dimensions is described by its normal vector, which is just a directed line segment which points perpendicular to the plane ABC, like that. It's a vector, a 3-dimensional vector, a directed line segment. Like this is a vector. Just point in different directions. All right, fine. If you write down the equation ax plus by plus cz equals to d, the set of x, y, z which solve that equation form a plane. That plane has normal direction ABC. That's it. So each one of these equations corresponds to a plane. Like equation 1 is a plane with normal 1, 1, 1. Equation 2 is a plane with normal 1, minus 2, minus 2. Equation 3 is a plane with normal 3, 4, minus 1. Right? And what we're finding is we're finding a point which is on all 3 planes. How does that work? Well, let's look at my binder for a second. This binder, right? At the moment, it's kind of like one plane, right? Now here's 2 planes. 2 planes intersect in what? A line, right? 2 planes intersect in a line. What happens when you add a 3rd plane? Like, oh, fine, here. Then they intersect the plane of the board at like that point. That's where all 3 plane equations are true. So this means that if you were to picture these 3 planes in 3 dimensions, the point where they intersect is 1, 2, 3. So that's geometrically what solving these systems mean. Now, in actual like applications, it could be like these equations describe like a particular way merchandise is sold in a store, and you've got 3 different kinds of merchandise, and you're looking for having the 3 different conditions met all at once. There's all kinds of like real world applications you could think of for these sorts of things. But anyway, you guys don't want to know about all that. We're just going to solve some equations. So let's solve this again. So I'll be boring. I'll keep the same set of equations. We're just going to solve it a different way. Right? I sure hope we get the same answer. Otherwise, it would be, embarrassing. So you guys can remember the answer, right? Right? Okay. Now, if you get a fraction as your answer on the test, there are 2 things that it could possibly have happened for this kind of problem. The one possibility is that you've made a mistake. The other possibility is that I set it up wrong. But I try to make these problems work out with whole numbers just because, it's easier for me to grade. So elimination, the goal is the same. Eliminate variable. How should we eliminate a variable? How about this? Equation 1 plus equation 2. What's that give me? If I add 1 and 2, what do I get? I get 3x minus z equals to 0. All right? Hooray. What happens if I... Oh, see, this is... How about 2 and 3? Let's look at equation 2, and let's look at twice equation 3. Why do I want to put twice equation 3? To get rid of, what do you say?
The Z.
The z. Yes, I think that's what it was. I've forgotten. I'm not disagreeing with you. I'm just expressing my own forgetfulness. Is that right? So 2 times equation 3. 2 times 3 is 6. 2 times 4 is 8. 2 times minus z is minus 2z. 2 times 8 is 16. And you guys understood my strategy, which was when we added these, or wait a minute.
Yeah, they don't exactly cancel out.
I don't want to add them. What do I want to do? Subtract. Yes. We have a winner. So, like so. All right, minus 4x plus 7y equals to... What the what?
Negative 2z doesn't cancel out negative 2z, it just makes negative 4z. Or am I missing something?
No. You're not missing anything.
Oh. No, they can't. I mean, minus a minus gives you a plus. So minus 2z minus 2z is minus 2z plus 2z. They cancel. That's not wrong. Now I should have not an 8y here. I should have a minus 9y. That's not a good sign.
How'd you get a minus 9y? 8
I said minus 1 minus 8 is minus 9.
Oh.
Yeah. Minus 6 minus 16 is minus 22. Now, all of this said, I regret doing that. Why do I regret doing that?
Where did the negative come from?
There's he's subtracting.
I'm
Okay.
subtracting the equation. Listen, this is not for the best. Why? Yeah. Right, so this right here, let's call equation 4, right? My goal actually was to find equation 5. What did I want? I wanted to find equation 5. I wanted to find equation 5 with no y variable. That's the key, no y variable. And I have failed in that mission, right? This has a y variable, it's not what I want. So I'm going to have to erase this. This didn't work. I'm so sorry. You know. All right. Are we clear why that's not helpful? Okay. So let me erase this. And also the whole subtraction thing was bugging you guys. So let's just make it go away. Right. So
For our subtracting, why do we add another subtraction sign?
we can subtract a negative number like it's allowed.
Yeah, but if you're already subtracting a negative 2 from a negative 2, I get there's a subtraction on the outside, but shouldn't you just know when you're subtracting a negative 2 from a negative 2, it should just be negative 4, you don't need that extra negative sign?
Well, yeah, but he's subtracting the negative, so that means you basically added the negative. Yeah. This is like negative 2 minus negative 2, but it's negative 2 plus 2. You know? So he wants to make it 0.
Two negative signs can be positive. So if you subtract. Just look at it.
So guys, the question then is we want to find an equation 5 with no y variable. Now here's the rules. We cannot use equation 1 and 2. We have to. We must use equation 3 for this to work. If you just use equation 2 to find another equation that doesn't have the y variable, what will happen when you put them together is you'll end up with 0 equals 0. I know this because I spent about a day learning this at one point, and I was very frustrated because I'd be like making correct steps, and I get back to 0 equals 0, like, that doesn't help. So we must use equation 3. How can we make y go away from equation 3? How about this? What I should have done is I should have multiplied equation 2 by 4. So if I do 4 times equation 2, I get 8x minus 4y minus 8z equals to minus 24. And equation 3, right, is 3x plus 4y minus z equals to 8. Now, this should go better, right? This should go better. We're just going to add these equations. What happens? We get 11x, the y's cancel, minus 9z equals to minus 16. That is what we're going to call equation 5. All right? So let's put them up. Let's put them up here. We've got equation 4 and equation 5. What do they look like? Equation 4 is 3x minus z equals to 0. Equation 5 is 11x minus 9z is equal to minus 16. I think you guys can see a good way to solve this, right? Should we use elimination to solve this? I don't think so. I think substitution's the way to go here. How should we substitute? Do you guys, what do you think? I mean, some of you have probably been screaming in your head, why don't you solve for z? Why are you writing it like that, right? Like, I'm sure some of you have already written z equals to 3x here, right? No, no, no. Add z to the other side, I get 3x equals to z.
You just subtract 3x, and then you're still left with negative z equals 3x. Then you've got to divide by the negative.
Yes. So what she's saying, fine. So this gives us 3x equals to z, which then tells me that z is equal to 3x because I can switch the sides, right? I don't have to, left can become right, right can become left, I can flip equations. This is allowed, right? So z equals 3x. Then what? Plug that in here. We've got 11x minus 9 times 3x equals to minus 16. I sure hope this works out to 1, otherwise it'll be so embarrassing. 11 minus 27 is what?
11 minus 20, that's negative 16.
Are you actually working it out, or are you just hoping I'm right?
I did it in my head. I wasn't looking at the board.
Suspect. Oh, okay, we're not looking at the board. All right, I mean, why am I? There we go. X equals to 1. So, woohoo. Then what? You go back to z, 3x, z equals 2. Z equals to 3, right? And what's y equal to? Well, yeah, I mean, yes, but how would you figure that out? So like maybe the first equation, right? X plus y plus z equals to 6. So we plug in the 1, we plug in the 3, we get y equals to 6 minus 4, which is 2. Right? So y equals 2, z equals 3, x equals to 1. Any questions? Yeah. Uh-oh. So what she was saying over there was that if you had 3x minus z equals to 0, right? Then you could say minus z equals to minus 3x, right? But then we'd have to divide by minus 1. both sides, and we get z equals to 3x. So
I'm just not as a fast thinker as you are, that's all. So it didn't click in my head.
it's all good. I would advocate trying to like work the steps I'm working alongside, not necessarily following each step necessarily. Sometimes it's a healthier thing to like start with the problem and just try to work it out yourself, and then just kind of like, I don't know, there's different ways of following a lecture like this that may be better or worse for you. Anyway, so now we've solved the same example twice. Let's solve a different example, right? Oh, one thing I should have mentioned. With this problem, it's really important on the test, once you find your answer, to like check it. Do you guys know how to check your answer? Like, here, let's try something. Example 3. Suppose I've got x plus y minus 13z equals to 7. X minus y plus 2z equals to 4. And x minus y plus z equals to 0. I just made these up. Here's my question. I'll put it over here. Is 1, 2, 3 the solution? Well, what would it take for 1, 2, 3 to be the solution? That would mean that when we plug it into the equation, it works, right? And it has to work for not just equation 1, not just equation 2, not just equation 3. It has to work for all three, does it? It does? Well, that would be so unlucky. I just made this stuff up. How about this one? 1 minus 2 plus 3, x minus y plus z, right? Which is equal to what? 4 minus 2, which is 2, which of course is not equal to 0. So, nope. Not a solution. I don't even need to check the other two. If it fails for one, game over. Now, if it works for one, you still have to check the next one. And if it works for that one, you still have to check the third one. You have to have all three working for it to be a solution, right? But one not working suffices to kill it. All right? So, all right, well, we've demonstrated that the solution's not 1, 2, 3. Let's find the solution. How should we do that? This problem, we should absolutely not use substitution. Substitution is the wrong strategy for this problem, for sure. The reason is this problem has not one, but two variables matching. You see that? Notice that this matches with that, right? What that means then is if we subtract equation 2, if we subtract equation 3 from equation 2, then we're going to get a really nice equation, right? Oh man, sorry. Old habits die hard. Example 3 for today. So let's subtract these two. What do we get? When you subtract x from x, you get 0. When you subtract minus y from minus y, you get 0. What's 2z minus z? Z. And 4 minus z is, 4 minus 0 is 4. Now we need to solve for z. Wait, well, z's already solved for. So okay, well, there. I mean, yay. Last class, I started class with this example and ended class with the harder problem. This time I decided to end class with the easy example to make you feel better about your weekend. All right? So I'm thinking about you guys. So now that I've got that, what do I do?
You gotta plug it in somewhere.
Yeah, I still need to. Oh! You know what else is nice? What's E1 plus E2?
Well, let's see. 2x minus 12.
What happens when we add these guys? Check this out, right? What happens? We get 2x. We get y. So the whole goal of elimination, guys, is to look for things matching up in the equation so we can either add or subtract to eliminate a variable, right? That's the name of the game with elimination. And it looks like we got something here. So minus 11z equals to 7. Oh, I can't do math. Yeah, minus 11z. 7 plus 4 is 11. What was x equal to? Oh, we don't know what x is equal to. Oh, so I'm supposed to, yeah, thank you. Plug z. Plug this right up in there. And that gives us what? 2x minus 44 equals to 11, which gives us 2x is equal to 55, which gives us x is equal to 55 over 2. You'll feel better about that if I write it as 27.5, right? Does that make you feel better? Like, is that better? 27.5? Is that correct? Okay. Then what? Then we got to find y. How should we do that?
Plug into equation 3 again.
Plug it. You say equation 3? I like it. So x minus y plus z equals to 0. But my x was 27.5. Y I don't know yet. Z is 4. Solve for y. Y is 27.5 plus 4. So apparently y is equal to...
Wouldn't that be negative 5?
I have to add y to the other side.
Oh, I see what you mean. Yeah.
As a general principle, guys, if you have an equation where you have two things on the same side of the equation and they have a different sign, when one of those things moves to the other side of the equation, they should share the same sign. So if I have a minus on y and I've got a plus on these two terms, if I write another equation where y is on the other side, it should be the case that if y is positive, those terms should also be positive. If y has got a minus out front, these also should have minuses. Like, there's something to think about here. You guys are having a lot of trouble with signs. You need to work on that. So let's see here. Anyway, what's that?
21.5.
Oh, well.
You said
Wait a minute. So how many people say 31.5? How many people say 21.5? All right. So as you guys know, math is done by consensus. So this is correct, right? It's not. It's like more people voted for this. So that makes it true, right? That's how it works. No. No. Any questions? All right. Well, have a good weekend. Let me turn off this silly camera.